Hello, BES and BFST class. You're welcome to yet another session, and this is descriptive statistics. Descriptive statistics basically looks at the describing features of data in a study. So here we shall be using some simple graphs or graphic analysis to create meaning out of data that we have. And to do this, we shall look at measures of central tendency, where we shall be describing the central position of a frequency of a group of data. And here we shall look at the mode, median, and mean of a data. In other words, how centered a data set is. Then the other measure is the measure of spread, where we come up with a summary describing how spread out the data or the scores of the data are. For example, if the mean of 100 students is 65 out of 100, it's not always a must that everyone has 65. So how spread out are the marks from the mean? So under that, we shall be looking at standard deviation and variancy. So some of the graphical methods, like we mentioned in our previous session, that we always have continuous, discrete, and qualitative data. So for continuous data, we can use histograms, line graphs, cumulative frequency curves, or box plots to describe the data. Then if the data is discrete, we can graphically represent it by use of column charts, bar graphs, and pie charts. And for qualitative data, we can still make use of the column charts, the bar graphs, and the pie charts. So for example, if we look at this data set, and we are interested in making a summary or describing the data, first of all, we can look at the mean, we can look for the mode, and we can look for the median. So, but that will mean grouping this data. Like you can see, this is like in intervals, less than 2,000, then from 2,000, from 4,000, from 6,000. So the first step when you're faced with such a data set is to create boundaries. And boundaries are created by reducing or subtracting what becomes the lower boundary, subtracting the figure we have. If it is a whole number, we subtract 0.5 and then add 0.5 to it to make an upper boundary. So if it has a decimal place, we increase the decimal places by 1. For example, if it was 2,000.5, the lower boundary would be 2,000.5 minus 0.05 and add the same to the same number to make an upper boundary. So whenever, and to do that, and we should always ensure that the class intervals are the same. In other words, the difference between the first class that we've created and the next should be the same. The difference between 2,000 and 4,000 should be the same as the difference between 4,000 and 6,000, and then the difference between 6,000 and 10,000. For example, here the difference is 2,000, the difference is 2,000, the difference is 2. So that when you're creating your boundaries, the intervals should be the same. So, and then ensure that each item is allocated one class. So if you look at such a data set, if I'm interested in getting 3,000. So when you're creating your class boundaries, that 3,000 should only lie in one boundary or in one class boundary. I shouldn't have, for example, between 2,000 and 4,000, then between 3,000 and 4,000. So there you get confused of where to put the 3,000. So each figure or each element should lie in one class boundary. So we are now going to look at one by one. So we start with the mean. So this is commonly also known as the average, and it is found by adding all numbers. This is for ungrouped data, and then dividing by the number of items in the set. For example, if I have 10, 10, 20, 40, and 70, and I want to get the mean, I'm going to add all of them and then divide by the number of items. How many are there? There are 1, 2, 3, 4, 5. So that will be 5. So next, the mean for grouped data. The other mean was for ungrouped data. So grouped data looks like this. We have data that is made in groups, for example, from 10 to 12, 13 to 15, 16 to 18, 19 to 21. But like I mentioned, when you come across such a data set, the first step should always be to create class boundaries, whereby if this is 10, my first class boundary, the lower boundary will be 10 minus 0.5, which is 9.5. And then the upper boundary will be 12 plus 0.5, which is 12.5. So this one will be 13 minus 0.5, which is 12.5, and this will be 15 plus 0.5, which is 15.5. So if you take note of that, the upper boundary becomes the lower boundary. The upper boundary becomes the lower boundary. The upper boundary here becomes the lower boundary. So once you don't have them, you have a problem with your data or with how you've added and subtracted. So to get the mean for grouped data, the mean is given by, it is always either the mean, the average, or x bar. And it is given by the formula summation of fx over n. N means the total population. So the total of the frequency is always our n. And fx, x are the limits or middle point, the middle point. So x will be the summation of the lower and upper boundary or upper class, and then divide by 2. So to get x for the first limit, or to get the midpoint of the first limit, we shall add 10 to 12. That will give us 22. 22 divided by 2, we get 11. So for the next boundary, we shall have 13 plus 15, which is 28. 28 divided by 2 gives us 14. 16 plus 18 is 34. 34 divided by 2, we get 17. 19 plus 21 is 40. 40 divided by 2 gives us 20. So these are the midpoints. So remember, the formula has summation of f of x. So to get f of x, we already have our frequency given to us. So f of x, we shall be multiplying the frequency by the midpoint. So 4 times 11, 12 times 14, 20 times 17, 14 times 20. So now these are the values of fx. Now to get the summation of f of x, we are going to add all of these. And their summation is 832. So we substitute that and then divide by our total frequency, which is 50. So therefore the mean is 16.64. So that is the mean for grouped data. Now we look at the median. The word median comes from the word middle. So now we are interested in getting the middle number in a data set. So if data is ungrouped, we should always list the data points in an ascending order and then look for the middle number. So if I have such data set, I have 23, 24, 26, 26, 28, 29, 30, and whether they are repeated or not, you're supposed to list each and every term, whether it is appearing 5 times or 6 times, you put it the way it is. So you now look for what is in the middle. So if I go side by side, 23, 33, 44, 31, 26, 30, 26, 29, so 28 is in the middle. So now that is the median. But now remember, this is an odd data set that has an odd number of of elements. But then there are situations where the data set has an even number of elements, where we are going to have two numbers in the middle. So in first, with such a situation, we get those two numbers and divide them by 2. What we get will be the median. So for example, here we have 23 and 34, 24 and 33, 26 and 31, 26 and 30. Then we are left with 28 and 29. So we don't have a middle part, a middle number in between these. So what we do, we add 28 and 29 and then divide by 2. What we get will be our median. So that was for ungrouped data, but in case the data is grouped, so the first step is to always construct what we call a cumulative frequency distribution, or we add a column that has cumulative frequency. So the next step will be to decide the class that contains the median. So, and how do we tell the median? If you look at a data set, we always have the total number or the summation, which is our total frequency, or n. So we look for that class that has n divided by 2, or where n divided by 2 lies. So that will be our median class. Then find the median by using this formula. So this is the lower class boundary of the median class, where we have n over 2. Remember, n is the total frequency. Then our f is the frequency, cumulative frequency before the median class. And then fm is the frequency of the median class. And I is the interval. Remember, we said the interval is the difference between the classes. The difference between 12 and 15, 15 and 18, 18 and 21 is what we call the interval, for our I. So if we look at an example, we are looking at the same data set. So the first step is to construct a cumulative frequency distribution, and that is by adding a cumulative frequency column. So how do we come up with cumulative frequency? So cumulative frequency, we start with the first frequency. Then to get the next figure in the cumulative frequency column, we add the previous figure we add the next figure to the previous to get what is here. So therefore, so we start with 8. Then to get the next, we shall say 8 plus 14, that gives us 22. Then to get the next term, we shall add 22 to 12, giving us 34. Then to get the next term, we shall add 34 to 9, giving us 43. Then to get the next term, 43 plus 7 will give us 50. And please always take note that the last digit in the cumulative frequency column is always our n, is always the total of the frequency. So once these ones vary, once your last digit and n vary, then there is a problem. So the last digit is always the total frequency. So like I'm going to repeat this. So we start with 8 with the first frequency. So it is cumulative in a way that it is additive. So 8, to get the next, we shall add 8 plus 14, 22, 22 plus 12, 34, 34 plus 9, 43, 43 plus 7, 50. And remember our n, from here, if we do the addition, our n is already 50. So you confirm this by comparing it to n. They should be the same. So once we have this, we are now going to substitute in our formula. So remember, our formula says lower class boundary. Now lower class boundary of the median. So remember, our median class is determined by dividing n by 2. So we look for a cumulative frequency where n over 2 lies. So when we divide 50 by 2, we get 25. So of these figures, where does 25 lie? So 25, so it can't lie here. So 25 is in this row of 34. So what is the class boundary? So we have 21 and 30. But remember, the lower class boundary, we subtract 0.5 plus the lower limit and also add 0.5 to the upper limit to create the class boundaries. So therefore, if I have my 34 the lower class boundary of that will be 20.5, because I'm subtracting 0.5. So this is my lower class boundary, 20.5. Then the next thing I'm interested in, we already have n as 50. Now remember, we said that f is the cumulative frequency before the median class. So our cumulative frequency that had the median class was 34. So what is the cumulative frequency before? It is 22. So meaning where there is f, we are going to put a 22. Then the other thing to look at is the frequency within. So frequency within is that frequency that has the cumulative frequency of the median class. So that is the frequency within. So when we come to the frequency column, our frequency within is 12. So that's why we have a 12. Then I, that is the interval. If I subtract the upper limit from the lower limit from the upper limit, what do I get? 10, 20 minus 10, 10, 30 minus 20, 10, 40 minus 30. And remember, it should be uniform. So that is why we have a 10 here. So when you do your body mass, the median becomes 24. And that is it with the median. Then we can also get quartiles. There is what we call the upper and lower quartiles. From the word quartile, we equate it to a quarter. A quarter is 1/4. Not so? So using the same method of the median, if I'm interested in getting the lower quartile, so I'm going to get n and divide it by 4 and do the same thing. So when you get n divided by 4, what you get will be the lower quartile range. So if I get my 50 and divide it by 4, what will it give me? So 12.5. So meaning, so where does 12.5 lie in the cumulative frequency? 12.5 lies in the 22. So meaning the median class will be 11 to 20. So the boundaries will be 10.5. So that is the lower class boundary, which is here. Then the frequency, cumulative frequency before that quartile, so it was the quartile, that frequency that had the cumulative frequency that had the median, sorry, the quartile, the lower quartile was 22, meaning the cumulative frequency before is 8. That's why we have 8. Then the frequency within is 14. So that gives us the lower quartile. Then the upper quartile will be 3/4, because the first quarter is a quarter, meaning if I want the upper quartile, I'm going to multiply that quarter by 3. So therefore I do the same. So my quartile class will be 37. So where does 37 lie? It lies in 43. So what is the lower class boundary of that? It will be 31 minus 0.5, which is 30.5. Then the cumulative frequency before, it is 34. Then the frequency within, 9. Now if I'm interested in getting the interquartile range, I'm going to subtract the lower quartile from the upper quartile. So what I've got as the upper quartile, if I subtract the lower quartile from it, what I get is the interquartile range. So that's it with a median. Now looking at the mode, a mode is that value that has the highest frequency in a data set. So if the data is ungrouped, if for example I have such values, you look out for what is appearing most, or which one has the highest frequency. I think we can all see that it is it 21? 21 is appearing 1, 2, 3. 21 is appearing 1, 2, 3, 4. Then 26 is 1, 2. Yes, I think the mode is 21. You look out for one that has the highest frequency. Then for grouped data, we are going to use a formula, and we shall also consider the class with the highest frequency. So this is the formula. So this is the lower class boundary for that data, for that with the class highest frequency. Then I is still the class width. Then delta 1 is the difference between the frequency of the model class or the class with the highest frequency and the frequency after the model class. We shall see this. Then delta 2 is the difference between the frequency of the model class and the frequency before the model class. So looking at the same example. So what is our class boundary with the highest frequency? So we come in the frequency column. The highest is 14. And this is the class limit 11 to 20. But what is the lower class boundary of 11? That will be 10.5. And I think that is what we have here. Then delta 1 is the difference between the frequency of the model class and the frequency after the model class. So the frequency before the model class, so 14 was our highest frequency. So the frequency before the model class is 8. So we are going to have our D1 as 14 minus 8. Then D2 is the difference of the model class and the frequency of the class after, the frequency of the class after the model class. So our frequency was 14, so the frequency of the class after the model class is 12. So our D2 will be 14 minus 12. So we come and substitute in the formula. Remember our I or interval is 10. So what we get is the mod. Remember, if we just look at the data set, what we get is the model class, but not the mod. So our model class was this, 11 and 20, but then the mod is 17.5. So the mod can also be obtained from a histogram. For example, if I had my diagram or histogram here, you look at for the highest. So if this is in terms of time, so the number of workers that have the highest, or the time that has the highest number of workers is our frequency. Sorry, is our mod. Now that is it with measures of central tendency. Now the measure of spread, we have variance and standard deviation, and we are basically going to look at grouped data. So and please take note that variance is the square of standard deviation, or standard deviation is the square root of variance, whatever way. So this is the formula that we are going to be using for variance. And when you want to get standard deviation, you just get the square root of what you've got. So if it is a population, we use sigma. And if it is a sample, we just use S. So sigma squared means variance of a population, and S squared means variance of a sample. But the formula basically, here we remember small n is a sample, capital N is a population. So if it is a population, the formula is summation of f of x squared minus summation of f of x, but when it is squared over n, then over capital N. Then here, for the sample, the formula changes a bit. Our numerator is now n minus 1. So standard deviation, like I mentioned, it is the square root of variance. So if it is standard deviation of a population, it will be the square root of sigma squared. And then for the sample, it will be the square root of S squared. So if we use the same data set, I want us to find the variance and standard deviation. So we can see that this is a sample. So what we do, remember, you look at the terms you have in the formula. We have x, remember x are the midpoints. We have f. So you make sure and then we have f of x, and we also have x squared. Remember, these two are very different. This is fx squared, meaning we're supposed to first get x squared, then multiply it with f. Then this is f of x but squared, meaning we're supposed to first get f of x, then square what we've got. So we make sure we have all that in our table. So f is given, x are the midpoints, 10 plus 12 divided by 2, 11, 13 plus 15 divided by 2, 14. Then we look for f of x. f of x, we multiply f by x. Then we get f of x squared. So meaning we first square x, 11 squared. Then what we get, multiply it by f. So we first square x, then multiply it by f. Please take note of that. So for the summations, this is summation f of x, this is summation f of x squared. Please take note here, you first square x for this last column, square x, then multiply it by f. Square x, multiply it by f. For example, the first one, it will be 11 squared. The first one is going to be 11 squared, which is 121, then times f, which is 4, giving us 484. Then the next term is going to be, the next term, x is 14, so 14 squared gives us 196, then 196 times 12, giving us 2,352. So please, these two are different. So here, we first square x, then multiply that square by f to get f of x. So this will be the summation f of x squared, which is this one. But here, it is summation f of x. This is f of x. So the total of f of x is the summation f of x. So meaning where we have f of x, summation f of x, I'm going to put, we are putting 832. So this was for summation fx squared. But this is summation of f of x squared. So this, then our n minus 1. So our variance is this, and our standard deviation will be the square root of variance C. So a reading assignment for you, you're going to read about a box plot and a stem leaf plot, and make short notes on not more than 3 pages. Please, I've not put this in the system for the reason that I want to make sure that you people listen to a recording. So whoever does not submit this assignment will mean they never listened to the recording. Thank you so much and have a good day.